and everything is under control. I saw your grades for the quiz. It looks fine, mashallah, بالأول والثاني. Tonight, inshallah, I will post the solution for the second quiz. Quiz was very simple. I don't know, some people get confused في free body diagram, but inshallah, I will put this solution. I will not put the solution that is available in the blackboard, but I will put a detailed solution. So you will, meanwhile, while you are looking at the solution, you will understand more and better. So today, Shabab, we have the new chapter. We will start chapter 6, which is electrical system and electromechanical system. The chapter 5 is omitted because we will not take it. It's about state space variable. But here we are talking about chapter 6, electrical and electromechanical system directly. We finished chapter 4, as you see. We took just one lecture. It's just Laplace transform of the output over the input, where we defined it as the transfer function. So in electrical system, we will do exactly the same way like we did for the mechanical system. First of all, we define the elements. What are the elements in electrical system? I am sure that all of you know the elements are the resistor, the capacitor, and the inductor. These are the elements. And we will see, like we have the inductor, we will see the laws that we are going to use to find mathematical modeling for electrical system. These two laws, I'm sure that you know them. These are the KCL, Kirchhoff current law, and the KVL, Kirchhoff voltage law. And once we define the elements and we define the laws, we will be able to define the mathematical modeling in electrical system in the same way we have done for the mechanical system. Because in the mechanical system, if you remember, we define the elements, the mass and the damper, and then the stiffness. And then we defined Newton's second law to find the equation of motion or to find the mathematical modeling. And we said also in mechanical system, we can use the energy method when there is no energy lost, when there is no damping, or when there is no friction. We can use the conservation of energy, and we solved some problems for you for conservation of energy. So today we will start by looking at the mechanical systems. The objectives for the whole chapter is to develop model of electrical circuit. When we say electrical circuit, something like this one, you have an inductor, and you have, for example, here the capacitor, and then you have, for example, here the voltage, input voltage, VI, and we are looking, for example, for the output voltage, VO. Remember, Shabab, here we have all, this is L and this is C. The variables here, the variables are the current, either it could be current or voltage. These are the elements that are variable. Maybe we take current as input and look for voltage as output. Or maybe the vice versa. We take the input voltage as input and the current as output. Or we may take voltage is as input to us, and we are looking for the output voltage, and so on. So like this example here, we have inductor with a capacitor. The current is passing I here. We have the input voltage, VI, is known, and we are looking for the voltage output across the capacitor. So remember, we have the passive elements that are the inductor, capacitor, and resistor, and the variables are either the current or the voltage. Like we did for the mechanical system, we had the spring, damper, and then mass, and we were looking for the displacement or the force. They were the two variables. The force and the displacement were the two variables we were looking for. So basically, we will develop models of electrical circuit, which include the application of Kirchhoff voltage law, KCL and KVL. I am sure that you remember what is KCL and what is KVL, obtain the circuit model in transfer function block and block diagram form. We applied the impedance method. Maybe this is new for you. I'm not sure if you saw it, the impedance method. This is the impedance method, which means in S domain, Laplace transform. We apply Newton's second law for electrical circuit and electromagnetic principle to develop model of electromechanical system. This is a mixed system in which it includes electrical part and mechanical part. So mixed system, and it consists of electrical part plus mechanical part. So basically, we use the electrical part to derive the mechanical part. We will have some small project for this course. Maybe next week, inshallah, I'll give it to you. We will have the mechanical part that drive the that give you the electrical part. So we will use the mechanical movement to have electrical part. This will be a small turbine, wind turbine. Maybe you saw it in the university here, and you saw it maybe somewhere in the kingdom. They use these turbines, the wind turbine, to generate electricity. So they take the mechanical part, and it will be transferred to electrical part to be used later on in home appliances or in energy. This is a clean energy system, we call it. So this is a small introduction about our lecture today. The majority of engineering system, they have at least one electrical part or one electrical subsystem. It could be a power supply that you are using for your computer or for your laptop or anything. Sensor, motor, controller, or acoustic device such as speaker. An understanding of electrical system is essential to understand the behavior of many other systems. The first thing we start by is the current and voltage. Current and voltage are the primary variable, as I have mentioned, used to describe circuit behavior. Current is the flow of electrons. It is the time rate of change of electrons passing through a defined area, such as the cross-sectional area of the wire. Because of electrons are negatively charged, the positive direction of the current flow is opposite to that of the electron flow. This is, you know it from electric two circuits. The mathematical description of the relationship between the number of electrons called charge and the current is I is equal to dq over dt. I, the current, is dq over dt, or the rate of change بالنسبة charge q. We can integrate this equation, and we have q is equal to integration of I dt. The unit of the charge q is usually it's measured in coulomb. The unit is C, which correspond to 6.24 10 to the power 18 electrons, moving from one body to another body in 1 second. This is in 1 second. This is the number of electrons moving to produce one charge, which is known as the coulomb. The unit of the current is ampere, which is coulomb per second. As you can see, ampere A should be coulomb per second. Thus, 1 ampere is 6.1 in another one to in 1 second. You can see, Shabab, this website here, if you don't mind, to see the electrons, how they are flowing in a circuit. They are moving in a circuit. Energy is required to move a charge between 2 points in a circuit. This is the energy. So the work per unit charge required to do this is called voltage. Here we have the voltage to do the work to produce 1 volt is the work per unit charge. The voltage difference between 2 points circuit is a measure of the energy required to move the charge from one point to another point. So the work done here represents the voltage. The unit of the voltage is volt, which is defined as energy per coulomb of charge. Joule is unit of energy or work and has the units of Newton times meter. Volt is equal to joule per coulomb and Newton per meter. So here, the volt, when we say volt, it's joule per coulomb. Passive elements, usually we are dealing with passive elements. These are the resistor, capacitor, and inductor. They do not produce energy. So they release energy or dissipate energy. Active elements like generator, batteries, solar cells, operational amplifiers, and we don't deal with this in this course. We don't deal with the active element. We just deal with passive elements. They do not produce energy. A voltage source, usually it's written, you can see it like this, for the alternative current, or for the direct current in the batteries, or it's electric current or a source current. We call this one either voltage source or a current source. Okay, Shabab, so these called the current to flow between one side of the battery to the other one, or the voltage that is varying in time for sinusoidal one, or that is constant through the battery. So voltage force is a device that causes a specific voltage to exist between two points in a circuit. Voltage may be time varying like this one, or time invariant like this one. The current source causes a specified current to flow through a wire containing this source. These are the schematic diagrams for the voltage and for the source. The resistor element is simply, as you can see, they are here shown in this size. They do not go beyond than 1 to 2 centimeters. Maximum is 2 centimeters, the size from here to here. So it's a linear resistor. We deal with linear resistor, and it is given by V over I. The resistor R is equal to V over I, voltage cross divided by the current passing through. And the symbol for this one is simply like this one. The current passing is I, and the voltage cross the resistor is given by ER or VR, yani voltage cross the resistor. And it is given by, the units is ohm. Ohm is simply voltage over ampere. So the voltage cross the resistance is ER or V. The current passing through the resistor is I, and the resistance is defined as V over I. So resistance does not store electric energy in any form, but instead it dissipates it as heat. So it's a source of dissipation, which is similar to the damping, exactly to the damping, because it dissipates heat. Real resistor may not be linear and may also exhibit some capacitance and inductance effect. We are dealing with ideal elements. Ideal elements means that the resistor does not have capacitance effect or inductance effect. So it is just a resistor. But in fact, on a real life, it has these two effects. But now to simplify the course, like we did for the mechanical system, we assume and we are dealing with ideal resistor that has no capacitance and that has no inductance effects. So this is the ideal resistor. The capacitance elements, the capacitance is two conductors separated by a non-conducting medium form a capacitor, like this one here. Two capacitors, two conductors from here. There is a medium in between these two here, one, and this is the other one. Medium is empty medium. It separates the two sides of the capacitor. Two metallic plates separated by a very thin dielectric material called the capacitor. You can see them here, Shabab, also. These are the examples. The capacitance C is a measure of the quantity of charge that can be stored for a given voltage across the plates. So the capacitance is given by C is equal to Q over AC. Q is the quantity of charge, and then divided by the voltage across the capacitor. The equation for that is I will be equal to C dE over dt. This is the original equation, but Q, since Q is equal to, or I is equal dQ over dt, So we can substitute these quantities here, and we get I is equal to C dEc over dt. So the dEc, or the change in voltage, will be 1 over C I dt. Or simply, if you integrate these two sides here, if you integrate both sides, you will have the voltage cross the capacitor will be simply 1 over C integral I dt, and you have the original charge or the original voltage into the capacitor. Because sometimes when you bring the capacitor, it has original charge at time t is equal to 0. That's why we are putting EC0. This is coming from the voltage that exists at time t is equal to 0. Although here we are dealing also with capacitance element, it means it has no resistance effect and no inductor effect. So although a pure capacitor stores energy and can release all of it, real capacitors exhibit various losses. These energy losses are indicated by a power factor, which is the ratio of energy lost per cycle to the energy stored per cycle. Thus, a small valued power factor is desirable. The units for the capacitor C is equal to farad, and it is coulomb per volt. Usually, Shabab, the unit for farad is very large. That's why we use, for example, microfarad and picofarad, 10 to the minus 9. So usually we go to the 10 minus 6 farad and 10 to the minus 9 farad. لأنه الانرجي or the farad itself, the unit is very huge unit. That's why we deal with micro farad and picofarad, 10 to the minus 9. This is the capacitance element. The inductor element is just the self-inductors, or that produce mutual inductance when you have a current passing through. These are some example of the inductor. If a circuit lies in a time-varying magnetic field, an electromotive force is induced. The inductive effects can be classified as either self-inductance or mutual inductance. The self-inductance, usually it's abbreviated by the symbol L, and it is written by EL over the rate of change of the current with respect to time. EL is the voltage passing through, and I is the current of the inductor, and we can relate the voltage to the current by this quantity. So from here to here, we can relate this one. So the voltage through the inductor will be simply EL will be L di over dt. Here, this is the symbol notation, and the unit for the inductor is Henry, or volt per ampere, or sometimes called Weber per ampere. The current I passing through the inductor IRL can be also written like this. IT, when you integrate these two quantities here, from here to here, you will find that I will be 1 over L, EL, integral EL from 0 to T dt, plus I at time to equal to 0. This is the current at time T is equal to 0, which is the constant of integration. We are dealing also with the inductor that is ideal, and ideal inductor, ideal, so it has no resistance effect and no capacitance effect. Because most inductors are coil of wire, they have considerable resistance. In fact, as you can see, the wire here is wrapped around. So the energy loss due to the presence of resistance is indicated by the quality factor Q, which denotes the ratio of stored to the dissipated energy. A high value of Q generally means the inductor contains small resistance. If you have, Shabab, time, can you go through this website here and look for this inductor and capacitor resistance? A summary of all these are like this. The capacitor here, the first element is the capacitor. The relationship between the voltage and current, if you have the current and you are looking for the voltage, So V will be 1 over C integral I dt. If they have the current voltage, which means if you have the voltage and you are looking for the current, I will be C dV over dt. And the relationship between the voltage and charge will be V is equal to 1 over C QT. This one, forget about it now. We will talk about it, inshallah, maybe next lecture when we talk in the S domain, because this is in S domain. We will not look at it now, but maybe next lecture, inshallah, or the lecture after that, we will talk about this one. So this is in S domain. The resistor V is equal to IR. This is Ohm's law, you know it. Once you are given I, and you are looking for the voltage. For example, here we take the current as the input, voltage will be the output. Remember, we have always this I and I of t and V of t are always our variable. We are looking for a given one, what will be the other one? If we give you I, we will ask you for V. Or if we give you V, we will ask you for I. That's why you have both relationship between the two variables, voltage current and current voltage. So I will be 1 over RV. For the resistor, we have V is equal R dQ over dt when you replace Q by I, when you replace I by dQ over dt. So remember, I will be dQ over dt. When we have the inductor, V will be equal to L di over dt, or I will be 1 over L integral V dt, or you can also substitute L will be dq over dt. Because you have I is equal dq over dt, when you differentiate I means and you are differentiating twice q. That's why we have here the second derivative of q with respect to time. Then already you have I is equal dq over dt. So di over dt means you differentiate this one twice. The symbol, or for the units, the capacitor has the units of farad, and usually it's expressed as C. The symbol is C. The resistor unit is ohm. The symbol for R is the units for R is ohm, and the symbol, as you can see, it's like this. The inductor has unit of Henry. The fundamental laws we are going to use, Shabab, hina, are the Ohm's law, first of all. How to remove this color, I don't know. Okay, it has gone now, Shabab. The current Ohm's law is simply V is equal to IR, you know it, or E is equal to IR. So the textbook used the voltage V or I. So V is equal to RI, or E is equal to RI. RI. This is known as the Ohm's law. Ohm's law. I is the current in amperes, E is the EMF, the electromotive force, and R is the resistance in the Ohm law. So this is the Ohm's law, which says the current in a circuit is proportional to the electromotive force acting in the circuit and inversely proportional to the resistance. That is, I is equal to E over R or V over R or N. This is known as the Ohm's law. You know, Shabab, when we have, like we did for the elements in for the mechanical system, if we have a arrangement like this one for resistors, they are in series arrangement, as you can see here. We have the current passing through here, I is the same as the current passing through I is the same as the current. So we can say the current is common. And the total voltage, the total voltage E will be E1 plus E2 plus E3. So we can write E is equal to E1 plus E2 plus E3. We substitute E1 by IR1, E1 by RR1, E2 by IR2, and E3 by II3. So you will see IR1 plus IR2 plus IR3. You can take I common from here and here, I common. So you will write the R equivalent, R equivalent, the passing here, we can substitute all this current by just one resistor, which is R equivalent. So R equivalent will be simply equal to sigma Ri. This is when we have the series arrangement. If we have a parallel arrangement like this one, you can see the voltage cross R1 is the same voltage cross R2, is the same voltage cross R3, and we can say that the voltage is common. In this case, if we look for the I here will be divided into three portions, I1 plus I2 plus I3. If we write I is equal to I1 plus I2 plus I3, we can substitute I1 by E over R1, I2 we substitute it by E over R2, and E3 by E over I3. So we can write I is simply E over R, I1 can be written as E over R1, I2 E over R2, I3 E over R3. If you take IE, if you take it common and you simplify both sides, you will have 1 over R equivalent will be 1 over Ri. This is when we have the parallel arrangement. The parallel arrangement, the voltage is common. The series arrangement, the current is common. And these are the resistance, the equivalent resistor. If I remember the quiz last night, you have, I think, spring here. So the force here will be K x1, but the force here could be, this is x1, and here you can have either this one, K x1 minus x2, or this one, see this same here, or you can have this K x2 minus x1, x2 minus x1, this is x2. So x1 minus x2 in this direction, but x2 minus x1 in this direction. So both, there were two correct answers. Both answers were correct. Either this one or this one. This is correct and this is correct. For the quiz yesterday. I will inshallah solve the quiz and post it tonight inshallah. I will not give you the final answer, but I will give you the details solution so that you will understand why you are, while you are solving, you will learn also at the same time. Now we have seen the elements. We will see, Shabab, Hina, we will see the laws that we are going to use. The first law is the Kirchhoff current law, or the node law. It's called the node law or KCL. A node is an electric circuit in a node in electric circuit is a point where three or more wires are joined together, like this one here. This is called the node, and we have some voltages or some current coming, I1, I2, and I3. They are coming, or they are going inside the node, and some other current are leaving or are going outside the node, in such a way that the algebraic sum of all currents entering and leaving the node is 0. We can say, if we take convention, sign convention, let's say, for example, we take positive sign for the current in and negative sign for current out, we can write it like this: I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. Or we can write this equation, we can write it also like this. It can be written in this form: I1 plus I2 plus I3 is equal to I4 plus I5. These are the current coming in on the left-hand side, and these are the current coming out on the right-hand side. So the summation of all current entering a node is equal to the summation of all current leaving the node. These are leaving the node, leaving, and these are entering the node. These are current entering the node. So you can write it also in vectorial sum like this: I1 vector plus I2 plus I3 plus I4 plus I5 equal to 0. When you remove the sign, when you remove the arrow, you will take the sign into consideration. It turns out to be like this or like this one. So the algebraic sum of all current entering and leaving the node is 0, or you can say it like this: the algebraic sum of all current entering a node is equal to the sum of all currents leaving the same node. This is the node law, or the Kirchhoff current law. Any questions, Shabab? Any question? Any question?
It is clear.
Okay, thank you. So the voltage law, a node in a point where 3, or maybe we said this one, this is not a node, this is the loop law, loop. Here we are dealing with a loop. I don't know why this one is coming here, talking about the current law. It's the voltage law. Normally it should be a voltage law, Shabab. Hina, the voltage law KVL is the sum of all current or all voltages through a closed loop is equal to 0. If we take the voltage cross this one, we take, this is a loop here. We take, I will give you a circuit here. This is a circuit. And this is another circuit here. So we have the voltage here. This is the input voltage source. This is one loop, and this is another loop. So the summation within the loop, مثلا هنا current I1 is passing through, here current I2 passing through. So the voltage within, inside this loop is 0. The total voltage within this one is 0. So the algebraic sum of all voltages around any loop in electrical circuit is 0. So the sum of voltage drops is equal to the sum of the voltage rises around the loop. So here we have this voltage. We can write the voltage in L di over dt plus Ri plus 1 over C plus E is equal to 0, or the voltage drop here is equal to the voltage rise here. So this is why we are writing it like this. If we take this loop also, the outside loop or the outer loop, we can write it in this form. 1 over C I dt is equal to E naught. So this is known as the Kirchhoff voltage law, KVL. KVL. So these are the two laws we are going to use now. Here, a rise in voltage, how we understand rise in voltage or the drop in voltage. If we take, for example, this circuit here, Shabab, a rise in voltage, which occurs in going through a source of electromotive force from the negative to the terminal, positive terminal here. So the rise here from negative, as you can see, we are moving from negative terminal to the positive. This is a rise in voltage, which is positive, as shown in figure 6.3, in going through the resistance in opposite to the current flow, as shown in figure 6b. Here, the voltage, the current, we say it's going from the negative to the positive. So the current is moving on the positive direction. So this is, we have a rise in voltage and rise in voltage. A drop in voltage will be the opposite, which is from the positive to the negative. So here we have a negative voltage, and here also we have a negative voltage because the current is passing through the direct direction, or in the same direction. So all these for you are electrical revision for you from the EE course. If we see, for example, this small circuit here, we have a resistor, and we have internal resistor that is coming from the battery. We can write Newton, I said Newton here, this is the current I passing through here, we can write KVL. In writing KVL, the summation of all voltages is equal to 0. So the voltage from E to B, EAB, plus the voltage from B to C, from the voltage from C to A is equal to 0. This is vectorial sum. If we take the positive direction, or if we remove the arrow, we should take the directions. We have the voltage E, positive. IR, the voltage through the resistance R here is negative, so minus IR. The voltage here is minus IR because the current is passing through this one. So we can write E minus IR is equal to 0. Or we can say the voltage passing through is simply E over R, which is simply here the Ohm's law. Voltage cross the total resistor, which is R plus R. Ohm's law, exactly. Voltage, it's the Ohm's law that is written in for this circuit. Similarly, we can do for this one. I leave it for you as an exercise. And now we go through modeling of electrical system. How do we do the modeling through the electrical system? We have a small circuit here, which is عبارة عن inductor and resistor, and this is the input voltage. And we are looking for I. What will be I? In the circuit shown in the figure, if we assume the switch S is open for t less than 0 and closed at t is equal to 0, obtain a mathematical model for the circuit and obtain an equation for the current I of t. So here we are looking for I, and it should be like this. E using the KVL, using KVL, E minus L di over dt minus Ri is equal to 0. Or simply you can write it like this. On the other side, take this on the other side, you will end up by having L di over dt plus Ri is equal to E. Now, Shabab, this is the current, current or the voltage that is input, and output is I. Always we have on the left-hand side, we have the output, and the right-hand side, we have the input. Remember, Shabab, here, the input is the current, the constant voltage E from a battery, for example. The current is, the voltage is something like this. Step input at time t is equal to 0. The switch was open switch. There is no current passing through or no voltage. But after that, when we turn this one, the voltage start passing. The voltage, we have voltage, and then this is our E. E will be constant voltage. Is a step input here. This is a step input here. So as you can see, exactly we have done this first order system. L, because it contains the first derivative, di over dt, and then I. And from here, you can also say that this is the first order differential equation that describe the current, how the current is passing through the capacity, the inductor and the resistor. So we will be looking for I, how I will behave. So when the mathematical model is given by this one, we can take, if you want, we can say I0 is equal to 0 at time t is equal to 0. There was no current passing through, but at time t, as I mentioned here, greater than 0 by just small than 0, there is current passing through, and we are looking for the equation for the current. What is this current equal to? Just like we have done for this one, if we take Laplace transform of both sides, we will have LSI plus Ri of S. We take I common, this will be equal to E of S. So at the end, if we take the ratio of I of S over E of S, it will be 1 over Ls plus R, where the E is the input and I is the output. We are looking for the output. And Ls plus R is the transfer function. The denominator of the transfer function is called the characteristic polynomial. It will give you characteristics of your system. It shows you that you have L, an inductor, and you have a resistor also. Another characteristic of the transfer function, Shabab, the transfer function should be independent of the variables. Only the physical parameter should be inside the transfer function. Yani we will not find هنا current in, we will not find the current, or we find voltage. We find only physical parameters that are L and R. L and R. Now, Shabab, if you can say, since we wrote our transfer function, we wrote it in this form, I of S, output over input, we wrote it in this form, I of S over E of S. E of S is equal to 1 over LS plus R here. If you see, Shabab, هنا, you can say I of S alone, لحاله, I of S will be G of S, or the transfer function, times E of S, times the input. This is what we are writing. We are writing I will be the input times the transfer function. Transfer function هنا is TF. The E is, it's a step function, so it will be E over S. It will have a value of E over S. لأنه it's a step function of magnitude E. So this is a step. And now we have LS over R. So you have two poles in S is equal to 0 and S is equal minus R over L. When you solve this one, you have two poles. You can write it in partial fraction. When you write it in partial fraction, you will find this relationship. You will find E over R as common, and you have 1 over S minus this one. Now, if you take the inverse Laplace transform of this one, it will give you E over R as common between the two. And then we have one coming from here. And this one exponential minus R over LT. 1 minus exponential minus R over LT. This is, as you can see, your voltage, or your voltage or the current starts from 0, and then it goes up to a certain value here, and it will stay constant, E over R. This is the step behavior. When you have a step input, what will be the step output of the voltage, of the current or voltage, or the step response? In the lab, if you remember, when we give you a step input, you have seen this behavior. You have seen this behavior like this. It's behaving the function or any output or any system. Last time in the lab, we took the step behavior for a first order system. This was the behavior, how it behaved. This is the input, step input. This is the transfer function. The output is this one. It's interesting, Shabab, to find the time constant like we did for the free response. Here, you draw a tangent at the origin. You draw a tangent at the origin here. It will cross the final value. Here, this is known as the final value or the steady state value. This steady state value, when it crosses it, you draw a perpendicular line here. This perpendicular line, if you calculate the time here, is called the time constant tau, and you have a value here. It crosses the response. The response here is 63.2%. 63.2% of the final value. Is this the final value? Here we have 63% of the final value. If you remember, when we have studied the free response, the free response was 37 or 36.8, if you remember. And the free response was doing this. I'll show you just this one, how we did it before. I'm not sure if I can get the file. So this is the response for the final value. give me just 1 minute, Shabab. I will bring the relationship for this one. I just want to remind you, I will draw a line for the free response and you will see what was it. This is when we have input step response. When we had the free response, I gave you this, if you remember. The free response here, it was at 37 or 36.8. The free response was behaving like this. This is the step response that is behaving like this one. I'll try to bring this, this website to show you how the response is behaving. Give me just 1 minute. So don't go, Shabab, please. Just give me the minute I ask you. Inshallah, it will work. Are you with me, Shabab?
Yes, we are with you.
Okay, shukran. Since you are with me, I really appreciate it. You can see the screen now, Shabab?
Yes, it's on.
What do you see, Shabab? You see the slides or you see the website? This one. Okay, good, great. Great, Mumtaz. This is what I want. Shabab, this is the step function. This is the E voltage, E here on the left-hand side, as you can see. And then the value is E. This is the initial condition. Our initial condition, now we put it 0. And this is the red one, is the behavior of the step response. The tau is you draw a tangent at the origin. It crosses the final line here, and then this will give you the tau. So the tau can be a measure of how fast the response will go to the steady state. If you remember, this is when we have ft is equal to constant, which means step input. If you remember, when we put ft is equal to 0, this is what we got last time. I gave you this response. This is for there is no force. It was the free response. And tau, see how we can calculate tau. Now for ft is equal to constant, we are dealing with this. The exponential is 0, but ft is constant. This is what do we have. The response is the red one. And this is tau. You draw a tangent to the origin, it will give you, and then it crosses the line, the steady state line at a point. From this point, you cross here the vertical line. It will give you tau, and it will give you at 63.2% the value. واضح شباب؟ Is this clear, Shabab? I will share back my file with you. Okay, shukran, Shabab. Since you got it right, I think now it's time for taking the attendance, and we will continue, inshallah, next. Okay, Shabab. Everyone, alhamdulillah, everyone is clear. كل شباب تمام. أموركم تمام, inshallah. Alhamdulillah, we will have our quiz next Tuesday, inshallah. We will try to give you enough time in which you can تعبروا على مدى فهمكم للمادة, and we will give you the opportunity to have many. We will have also written exam. Written, you will have part in which there will be a written part, small exercise that you will solve and you will submit at the same time. in addition to this, لأنه we want to give you chance to show us the steps how to solve. This is missing part in the blackboard. When you have multiple choice question, this part is missing. You don't see it in the exam. So I want to give you a chance to have partial credit for the part that you are writing. Let me take the attendance. هاني تفضل.
زاد فضلك دكتور، بالنسبة الكوزات عموما والمياجر، ممكن بس تزيد الوقت شوي لأن الوقت مرة قصير، يعني خصوصا لما يصير السؤال ما تدري وش السؤال اللي بعده، يعني هل يكون أطول ولا أقصر؟ زي الكوز الماضي كان 4 دقائق بس. I took much time in the first question, which was difficult, so I couldn't solve.
Time it's not time is measured يعني effectively. Let's not waste. We can discuss this inshallah next lecture. Let me just take the attendance. The time I think is ما في جدال. It was enough. العوة منير. شكرا. فيصل كيف حالك؟ المسعودي عبد العزيز. أهلا شيخ مسعودي كيف حالك؟ قحطاني حسين. علي حسين. المحمدي عبد العزيز. شكرا. قحطاني عبد الكريم القحطاني. شكرا. علي. شكرا علي. كيف حالك علي؟ الرميح هاني كيف حالك؟ القرني علي. أهلين. زهراني فارس.
موجود.
أهلا وسهلا فارس، كيف حالك فارس؟
الحمد لله طيب.
حمدان عبد العزيز. عزيز الحمدان. أهلين عبد العزيز. الشريدة محمد. كيف حالك شريدة؟ بخير إن شاء الله.
خير نعم يا دكتور، بشر عنكم أمورك طيبة.
الحمد لله. العجمي مبارك.
يس دكتور.
أهلا وسهلا العجمي، كيف حالك؟
الحمد لله، كيف حالك دكتور؟
الله يبارك فيك. طليحي يوسف وكيف حالك يا يوسف؟
الحمد لله يا دكتور وشك.
يوسف ولا يوسف؟
لا يوسف بس.
يوسف بالسكون ها؟
صح.
الزاير حسان كيفك يا حسان؟ الجهني. الزاير حسان موجود. الجهني موجود معنا اليوم. الجهني نادر. النادر موجود نادر بس ما يسمع. العقيل رائد
موجود يا دكتور.
اهلين العقيل رائد. اهلين شباب. راح اخلي الاوفيس اورز بعد المحاضره هذه تكونوا موجودين، واللي عنده سؤال يسالني على طول. يعني ممكن اجلس لكم مده نصف ساعه، واللي عنده سؤال يسالني على طول.
دكتور لو سمحت ما سمعت اسمي.
بعد ما انادي بليز، بعد ما انادي اللي عنده سؤال ممكن يسالني بعد ما اخذ الاتندنس. الدرويش عبد الله.
حاضر دكتور.
اهلا وسهلا درويش.
اهلا وسهلا.
الجهني نادر جاء ولا لسه ما جاء؟ شرفونا حسين.
حاضر دكتور.
حسين كيف امورك؟ ان شاء الله تمام.
الحمد لله، يعطيك العافيه دكتور. الحمد لله.
بشرني ان شاء الله بخير الامور.
الحمد لله احسن الحين.
الحمد لله. الدبيس اهلين علي. اهلين. المحمدي سلمان كيفك سلمان؟ البشر علي البشر كيفك ان شاء الله اليوم تمام؟ الجارودي حسان كيف حالك؟ الحمد لله حسان مدام. الرشودي محمد. رشودي، بشرني يا رشودي، كيفك؟ ان شاء الله بخير. هاشم ناصر.
الهاشم حاضر دكتور.
اهلا وسهلا بالهاشم ناصر، كيف حالك؟
يا
مشرفنا.
هلا.
العواد سلطان. اهلا بالاخ عواد سلطان. السوبدي علي. اهلا بالشيخ السوبدي علي. عبد اللطيف، عبد اللطيف، عبد اللطيف كيفك اليوم؟ ان شاء الله بخير. عبد رب النبي موسى. موسى كيف حالك؟ تمام. زهراني عبد العزيز. عبد العزيز كيف حالك؟ العتيبي، العتيبي فهد. العتيبي. كيف حالك فهد؟ كيف امورك؟ تمام. المحمدي يزيد. يزيد كيفك يا يزيد؟ الخباز منتجب. منتجب كيفك؟ ان شاء الله بخير. والله مين ما جانا اليوم لسه ما سمع صوته؟ نادر الجهني. نادر تفضل. حسين يس. كم رقمك حسين؟ حسين القحطاني، حذرتك يا حسين.
قدام فضلك يا دكتور، بس ناديت على اسمي ورديت، ما ادري هل
لا
ودي
حذرتك
مختارته.
حسين.
أجل،
حذرتك
شكرا
حذرتك.
شكرا. السلام عليكم.
مين معنا؟ القحطاني الجهني نادر جاء ولا معنا؟ طيب طيب، شكرا. شكرا لكم شباب. مين عنده سؤال الآن يتفضل. نايف الصبح يتفضل.